Welcome to 7th grade math. This is lesson 2.2, so that's week 2, lesson 2, and we're talking about the order of operations. So let's start by recalling some key words that we're going to need to know so that we're all speaking the same language. Take note of these. So do you remember what I said when I said to take note of something? That means that you're going to write this down however you remember, maybe draw an illustration, or however it is that you're going to remember to take notes on your own paper, or whether you screenshot it, however you do, take note. This is important information. So first we're going to recall what operations are. Operations are simply what we're doing to the numbers. So you'll be seeing addition, subtraction, multiplication, and division. Those are operations. When we talk about exponents, you may hear people say power or index. That tells us how many times we're going to use that number in multiplication. And I will go on to talk more about that here in just a little bit. And then finally, order of operations. That just refers to what we're going to do first, what we're going to do next in order to come to an accurate result. Okay, so let's get started. This semester, you may have heard it called PEMDAS or some other things, but the acronym we're using to help us remember what order we're going to do things in our problems is called GEMS. Okay, so GEMS, GEMS. So that means that the first thing we're going to do in any problem that we look at is we're going to look for grouping symbols. And grouping symbols might be parentheses, they might be brackets, they might be absolute value bars. It could be a lot of different things, but we're just looking to simplify that area of the problem first. Okay, so that's first. Next, we will look for exponents. So an exponent is a base to a power. So you might see like 5 squared or another number raised to a power. That's an exponent. Then we'll be working on multiplication and division from left to right. So multiplication might be shown by that little X or maybe a thick dot. Division, you might see something that looks like this, or you might see a ratio. You might see one number over another. That just means the top number divided by the bottom number. And then finally, we will look for subtraction and addition left to right. So just like reading a book, we go left to right. So subtraction and addition. And that, if we go through all those steps, should leave us with a simplified answer. I want you also to notice that aside from the actual word, GEMS, G-E-M-S, if you look at this picture, like as a diamond, it's larger at the top and narrows down to a point at the bottom. It gets smaller at the bottom. And that kind of symbolizes also how when we work on simplifying using GEMS, we're going to have the more complicated piece will be listed at the top, and each step we go through will bring it down to narrow to a more simplified answer at the bottom. Next, we're going to take a minute to do some practice. There will be some questions that pop up to the right of this screen for you to go ahead and answer those questions before moving on. All right, hopefully we answered all of those right. That just kind of reviews that we're going to be using GEMS. So grouping symbols, exponent, multiply or divide left to right, subtract and add left to right. So just remember that's GEMS. We're going to take our more complicated answer and simplify it down to something cleaner at the bottom. So let's practice with some of these grouping symbols. So grouping symbols are just going to organize the math that we do. It's going to show us where the group starts and finishes to keep it clear. So here's some examples of grouping symbols. Well, it looks like an example of grouping symbols. Let me fix that. There we go. There should be a parenthesis there because that would change it depending on what we're doing. So the first thing I'm going to do is I'm going to look, do I have any grouping symbols? Well, in this first one, I do have grouping symbols. This 5 plus 7 is in parentheses. That's a grouping symbol. So what I would need to do is just kind of focus in on that. So 5 plus 7 is 12. Okay. But now I can't get rid of that 2 times in front of it because I haven't done anything with that yet. So I have to keep that there. Now I'm going to look at it again. Do I have any grouping symbols? Well, I have that parenthesis around the 12, but there's nothing to do inside there. It's just a single term. So now I can look at, well, what is there left to do? I've got 2 times 12. Well, that's pretty simple. That's multiplication. That's 24. So there's nothing else that can be done, and much like the picture of that gem that we had before, we started with something more complicated, and it narrowed all the way down to just that single term of 24. So let's look at the next one. 2 times the absolute value of negative 4. Do we have any grouping symbols? Well, I see this absolute value around the negative 4. So the first thing I'm going to do is I'm going to have to try and recall, what does absolute value mean? In the parentheses before, I had an operation that I could tell was there. This is absolute value. Well, from our last lesson, we know that absolute value, I'm going to write this down somewhere just so we remember. Absolute value is a distance, right? It is the distance from 0 on a number line. So if I have a number line and I've got 0, and then my number that I'm dealing with right now is negative 4. So negative 1, negative 2, negative 3, negative 4, and the number line could go on either way. And I want to know the distance from 0 to negative 4 on the number line. Well, I can just remember the distance is always positive and say, well, it's going to be positive 4. But if I'm not sure, I can draw out my number line and hop 1, 2, 3, 4 spaces. Okay, that helps me out. So I know that the absolute value of negative 4 is actually positive 4. I still have that 2 times in front of it because I haven't done anything to it yet. So it didn't disappear. It just kind of waited for me. And now I'm just left with this simple 2 times 4, which I remember my math facts tells me is 8. And again, we can think of that visual if you want to of a diamond that started out more complicated and then narrowed down to a simplified expression, that just that term, that 8. So let's look at our next one. I've got 2 times, and then I see these brackets. 5 times the expression 2 minus 1. Okay, looks a little bit more complicated, but I'm not going to be intimidated because I am going to remember gems and go through my orders here. So my grouping symbols. I see this grouping symbol, this bracket here, and it closes over here. But then I'm looking inside of there, and I'm like, uh-oh, there's another grouping symbol. Well, I just start back over, and I move into the interior there, and I look at the inside most. And so the inside most grouping symbol there is that 2 minus 1. So what is 2 minus 1? Well, that's just 1. But now I have to remind myself that the other stuff did not just vanish. It's still there. I've still got 5 times that 1. Okay. I can put the parentheses around it if I want to. I don't have to because it's just a single term now. Now I'm going to start over. Do I have any grouping symbols? Well, I still have grouping symbols. I have that 5 times 1. So now I need to deal with that. 5 times 1 is simply 5, okay? And I can't forget that 2. It didn't disappear. It's still hanging out there waiting for its turn. Well, now I've got that grouping symbol of the brackets around there. I could drop that if I want to because there's nothing more complicated going on in there. It's just a term. But all I'm really left with is 2 times 5, because see, there's no operation shown in between there, so we can assume multiplication. And 2 times 5 is simply 10. So the same thing happened. I started with something more complicated, and I simplified it down to the number 10. Next, we are going to talk about exponents. Exponents tell us how many times we're going to use the base in multiplication. It does not mean to multiply one number by another. So if I'm looking at that 5 to the second power, it does not mean 5 times 2. Absolutely not. Instead, think of how many copies. It indicates repeated multiplication. So in the example of a to the n, first we can identify the big number is the base number. That's the number that's going to be copied. And the exponent might be called power or index exponent. That is how many times we're going to copy that. So let's start by looking at our first example, which is 5 to the second power. Well, which one is our base and which one is our exponent? 5 is our base. Okay. And 2 is our exponent. So we know we're going to take 5, because that's my base, and I'm going to write 2 copies of it. There's one, there's another. So now let's read it. So this means the same thing as that. 5 times 5, which is the same thing as 25. Okay, not so hard, not so hard. Let's try it again on another one. On 2 to the third power. My base is 2. So that's what's getting copied. And my exponent is the 3. So that tells me how many copies. So I'm going to, let's see, what is that going to be the same as if I wrote it out as multiplication? Well, that's 2 is my base, and I need 3 copies of 2. So 2 times 2 is 4. 4 times 2 is 8. So 2 to the third power can be expanded out as 2 times 2 times 2, and that also simplifies to 8. Okay, we're going to take a minute to complete this practice activity. There will be some questions that drop down to the right that will help us fill this out. And again, you can write it down on paper, you can screenshot and use your writing tools, or you can mark this up however you need to help remember this information. All right. I'm hoping that we all were able to come to these correct conclusions. If you're having trouble with this concept, shoot me off a message. See me in class. If you're one of my remote kids, this is a good thing that we can work on during our Zoom, or, like I said, just send me a message. I'd be happy to help you at any time. All right. Let's try our next step of GEMS. We've already talked about grouping symbols and exponents. Well, now we are at multiply and divide left to right. So starting with our first example, it's just like left to right, like reading a book. Let's kind of go through it here. Well, here we have a grouping symbol. So what is our grouping symbol? 5 minus 2. Well, I know that that's just 3. So I'm left with 3 times 3, and it's left to right. It really doesn't make a difference in this one, does it? Because it's all the same. It's just 9. Let's see if it's any different on the next one. Well, I've got another grouping symbol. So 9 divided by the expression 5 minus 2 times 4. Well, 5 minus 2 is in a grouping symbol, so I need to do that first. So that turns into a 3. But the rest of my problem did not just disappear. It was just waiting for its turn. So now I've got something where I'm looking for multiplication and division, but I've got more than one thing to do. So let's work left to right. Let's start with 9 divided by 3. Well, 9 divided by 3 is 3, but I still have that times 4. It didn't go away. It was waiting for its turn. Now I'm left with 3 times 4. All right, so I followed GEMS, and I started with something more complicated and narrowed it down to a simple answer. Our final example for this section, let's see, grouping symbols. Nope. Exponents. Yep, we have an exponent right here. So what does that mean? That means my base 2 has 2 copies. So 2 times 2 is 4. Well, let's rewrite that as 4. But my 8 and my division, they didn't go away. They were just waiting for their turn. Now, left to right, 8 divided by 4 is simply 2. Again, take note of these, write down examples if you want. You can always pause the video. The final thing in our gems, the final operation, we've already done grouping symbols, we've looked at exponents, we've multiplied and divided left to right, and now we're going to look at subtracting and adding left to right. So let's just get after it. First thing we're going to do is we're going to look for grouping symbols. I see that I have brackets that kind of enclose this whole thing right here. And then I also have parentheses right here. So I want to look inside the brackets and start my gems all over. And I do have grouping symbols inside there. So let's work on that. What is 5 minus 1? Well, easy enough. That's 4. But now I can't get rid of the other stuff. It's just waiting for its turn. It didn't vanish. Okay, now I'm going to ask myself again. Let's start back over. Do I have any grouping symbols? Well, I still have this big old grouping symbol right here. So I'm going to go inside there. Let's look at my gems inside there. Are there any grouping symbols inside there? There's not. Are there any exponents? Oh, there actually is. Let's look at the exponent. I have 2 to the 3rd power. So 2 is my base, but I have 3 copies of it. So 2 times 2 is 4 times 2. 4 times 2 is 8. Okay, so that is the same thing as 2 to the 3rd power. Okay, so I'm going to go ahead and substitute that in there. I have 8. Now the rest of it didn't disappear. It was just hanging out waiting for its turn. So I still have this and plus 1. Okay. Well, this turned out to be an example more for grouping symbols than anything else. Let's see. Do I still have any grouping symbols? In fact, I do have this here. 8 divided by 4 is 2. Plus 1 did not go away. It just hung out there, left to right. I'm going to do 2 plus 1 equals 3. And 3 is my most simple answer. I think I'm going to have some practice problems that are going to maybe challenge us a little bit more on the actual multiplication, division, adding and subtracting. This one was a lot about grouping symbols, but we were able to use all of those pieces we've brought together. There are those practice problems I was talking about will be over to the right side of this video. Finish those up. Once you're done with those, then you can move on and watch the rest of this where it will give you the wrap up and a look ahead. Okay, let's wrap this up by just remembering that we are dealing with gems to help us remember the order of operations, where we first will look for grouping symbols like parentheses, brackets, or absolute value. Then we will look for exponents, which is a base to a power. Then we will multiply or divide from left to right. And then we will subtract or add from left to right. And finally, a look ahead at next week. Next week, we're going to focus on adding and subtracting integers, getting some really good practice into that because it's something you're going to use for the rest of your academic career and probably on into your adult life. People use adding and subtracting integers, so we want to be proficient at that. We're going to also work on using color counters to make zero pairs and discuss the additive inverse. Hopefully that'll help you visualize exactly what it means to like subtract a negative number or add a negative number. But that's all for the next lesson. So you guys work on your choice board and enjoy the rest of your week.